Assalamualaikum and good day everyone. Welcome to Semester 1 2024-2025 session. I am Dr. Hafiza and I will teach you the database subject for the next 14 weeks. I am excited to get started on this journey with you. Since this is our first meeting, let's look at our lesson plan. You can download your lesson plan from the author. Now, let us look at the outcome of our course learning. You are expected to design and construct a relational database at the end of this course. Next, you can use the current technology and tools in database development to build small to moderate scale databases. Lastly, you will acquire skills in analyzing problems and producing solutions in database development based on the current situation. For CLO1, the learning process will include lectures and student-centered activities. To assess your understanding of CLO1, you will be evaluated through a test, project product, and final examination. For CLO2, the learning approach will involve practical sessions, cooperative learning, and student-centered activities. Your understanding of CLO2 will be assessed through a laboratory test. For CLO3, you will engage in cooperative learning and student-centered activities, and your assessment will be based on a presentation. Please note that a total of 9 topics will be covered over the course of 14 weeks. So, are you ready to dive into topic 1 and get started? In this topic, we'll explore some fundamental database terminologies, examine the traditional file system, and discuss how the database approach can address the shortcomings of the traditional file system. As an introduction, I would like to highlight on the importance of the data. Data is a raw material that is an important asset in our daily lives because having accurate and sufficient data leads to correct decisions and actions. The most common method to collect data in a computerized system is applying the database concept. Do you know Malaysia is the first country in the world to use a smart card that contains all the card owners' information? My card combines chip technology and the latest biometrics. Let us look at several examples of database applications that we often use in our daily lives. The first example is at the supermarket. The salesperson will use a scanner to read the product code bar when you purchase items in a supermarket. After scanning, the system will identify the product and produce a receipt containing the name and price of the product mentioned. The system will also check and update inventory records to indicate total sales and remaining stock. This system is linked to the product database. If the product stock is less than the stock control limit, the system will signal instructions to order new stock quickly. The product database system ensures that supply is always sufficient and records of purchases and sales are kept neatly. Data stored in a product database include the product price, date sold, salesperson's name, and product name. Now, let us move on to the second example, which is the library. In the past, the search for information in a library was done through a catalog system. Libraries now have a database system to store information on books, journals, proceedings, newspaper articles, magazines, working papers, and other such material. This computerized catalog system is used to search for material in a library. The search method uses keywords like title, author, subject, publisher, and year of publication. This database catalog system enables you to search for and obtain information quickly. The university's database systematically stores information about staff, students, and courses. The database holds details for staff such as name, address, worker number, post, courses taught, and salary. Similarly, student data includes matriculation number, name, address, department or faculty, course registration for each semester, and grades. At UTHM, many of you have used SMAP online to register for courses each semester, and this is also the platform where official results are published. This digital system streamlines processes, reduces paperwork, and ensures all data is easily accessible and well organized, showing how databases are vital in modern educational institutions. For a clinic, when the number of patients increases daily, records for storing patient information also increase, and much space is needed to keep such records. Information on each patient includes identity card number, name, address, telephone number, date of treatment, type of treatment, medication, and payment. The old method of using cards requires much space to store such information. With the use of information technology, the doctor merely has to key in the identity card number of the patient, and information on the patient together with previously given treatment will be displayed for his reference. The data on patients provide facilities to produce records, for example, patients who have been given treatment and payment for each treatment received by each patient. Suppose you intend to go to Penang for a holiday through a travel agent. In that case, the agency must access several databases containing the holiday and flight details based on your yearning. These agencies will establish connections to several related databases. One such database is the flight booking system, which stores flight rates and schedules data. When you make a holiday reservation, the database system must make all booking arrangements. The system needs to make sure that no two different agencies make the same holiday reservation or book the same flight seat. For example, if a flight from Johor Bahru to Penang has only one flight seat left, the database system needs to ensure that booking by only one agent is allowed, and other agents must be informed that all flight seats are fully booked. At the same time, the travel agent may have a different database system for producing customer invoices and receipts. Let us go over some key terminologies for this course. Data refers to basic facts or raw elements that by themselves have no inherent meaning in the context of a problem. Conversely, information is data that has been processed and structured in a meaningful way, enabling decision making. The environment is the organization or context in which a database is created and maintained. An entity is a unique object or thing that can be identified within that environment. Attributes are the characteristics or properties that describe an entity. A record is a collection of related attributes or fields that pertain to a specific entity. A file is a collection of records related to a particular entity. And finally, a database is an organized collection of files and records that stores and manages large sets of related information. Let us consider the following examples. The university as an environment. The data collected here includes student names, matriculation numbers, subjects, assignment scores, test scores, and exam scores. This raw data is processed to generate useful information such as the average test score, the number of students scoring below 20, GPA and CGPA. Examples of application programs in this environment include the Student Assessment System, SMAP Online, and TCIS. In another example, a supermarket serves as the environment. Data like item names, buying prices, selling prices, quantities, suppliers, and dates are captured. Once processed, this data provides valuable insights such as profit or loss, the best-selling item, and the highest daily profit. Applications commonly used in this scenario include inventory management system and point of sale system. Before the concept of the database was introduced, data in computer system was stored using a traditional filing system. As such, you need to know the traditional filing system before you thoroughly comprehend the database system concept. Understanding the meaning and problems of traditional files enables you to avoid and repeat the same mistakes. Indirectly, you could also conduct the conversion process from a traditional file to a database system. An organization's filing systems store all internal and external information related to specific projects, products, tasks, customers, or workers. Usually, there are many files involved, and for security purposes, each file is labeled and kept locked in different cabinets or a safe place. You have your filing system at home for bank statements, bills, favorite recipes, etc. When you intend to find detailed information, you will open your file system and search one after another until the information you require is obtained. You may also have developed an index system to assist you in obtaining information at greater speed. When computers were first used, records were stored in different electronic files, each using more or less the same format as a filing system. It cannot be denied that with the electronic file, Accessing information is faster and more accurate compared to the manual method. However, there are still weaknesses in the processing of the filing system. A file-based system works well when the volume of stored data is small or moderate. However, it becomes inefficient and problematic when dealing with larger volumes of data or when multiple files must be referenced simultaneously. The key weaknesses identified in an ordinary filing system include duplication of data. When data is not centralized, it leads to uncontrolled duplication. For example, the same information might be stored in different files without coordination. Second is data separation. When files are stored in different locations, it becomes difficult to retrieve combined information. This can lead to problems if one department updates data, but others must reflect the changes. Third is data format dependency. When there is a change in file formats, application programs must be rewritten or adjusted. This dependency causes inefficiency when dealing with various file formats. Next is the file incompatibility. Files processed by one programming language may not be compatible with another, creating issues in communication between different systems or programs. Lastly, difficulty in representing organizational data. Due to a lack of standardization between departments, it is challenging to present data to reflect the actual organizational structure. This can obscure the relationships between records across different files, making it difficult for users to extract meaningful information. In traditional file systems, as described earlier, data is often duplicated, stored separately, and dependent on specific formats and programming languages, leading to inefficiency and inconsistency across departments or units. These systems also need help with file incompatibility and complexity when multiple files must be referenced simultaneously. A database represents a more advanced approach to managing data, as it is a centralized collection of related data shared by various users. Instead of scattered data in different locations and formats, a database system allows for organized and efficient data management to meet an organization's information needs. For example, a database management system, DBMS, acts as software that enables users to define, create, update, manage, and administer the database. With DBMS, users can easily control access to data and perform operations without the difficulties encountered in traditional file systems. Data in the database is accessible through application programs written in specific languages like Pascal, COBOL, and C++. These programs interact with the database to retrieve, insert, or update information as needed. The DBMS overcomes the weaknesses of traditional file systems by offering centralized control over data, reducing duplication and inconsistencies. Data independence means changes in the file format or output do not require rewriting application programs. Standardized access to data across multiple departments, facilitating communication and data sharing within the organization. Next, improve security and access control, ensuring that only authorized users can access or modify specific data. The 5 components of a DBMS can be explained as follows. The first one, hardware. This refers to the physical devices required to run the DBMS, such as servers, storage devices, and the network infrastructure. The hardware supports the functioning of the database, ensuring data storage, retrieval, and processing. Next is the software. The software component includes the DBMS and any application used to access and manage the database. This also includes the operating system and network software that support the database operation. As for the users, there are different types of users interacting with the DBMS, such as database administrators, developers, and users and system analysts. Each group has different access rights and roles within the system, such as creating, updating, or querying data. As for the procedures, these rules, guidelines, and instructions define how data is managed and used within the DBMS. Procedures ensure the system operates effectively and securely, covering aspects like backups, recovery, and database maintenance. Data is the most critical component, as the data itself consists of raw facts stored, organized, and manipulated in the database. A DBMS allows for efficient management and retrieval of this data. Before we wrap up our class today, please take a moment to review the slide which demonstrates how Susan uses a database in her daily activities. This example should help you understand how databases are applied in real-life scenarios. Please comment in the section below to confirm that you have watched the video. This will serve as proof of your participation. I hope you all have a wonderful day, and I am excited to meet you in person next week. Thank you and take care. Bye.